The vast, deep ocean, it's basically our planet's life support system. And it is in serious, serious trouble. A brand new report just came out, and it looks like the ocean has failed a critical health check. So in this explainer, we're going to break down exactly what that means for all of us. Okay, let's dive in.
And that is a huge question. The answer, it impacts pretty much every single person on this planet. Because, this isn't just about some distant coral reef or far-off ecosystem. No, this is about our food, our economy, and really the stability of the entire planet. Let's just start with one number, 3 billion. That's how many people rely on the oceans as their main source of protein. So you see, this is not some abstract environmental thing. It is a direct threat to global food security, a really big deal. And here it is, the big headline from the 2025 Planetary Health Check report. For the first time ever, we have pushed the ocean past a critical tipping point. You can think of these planetary boundaries as like the safety rails for humanity, the safe zone we need to stay inside. And we just blew past a major one. So how on earth did we get here? Well, to really get what's going on, we have to dive into the chemistry. And believe it or not, it all starts with a change that is so small you'd think it wouldn't matter at all. Okay, get this. Since the start of the Industrial Revolution, the pH of the ocean's surface has dropped by just 0.1. 0.1. Now, I know what you're thinking. That sounds like nothing, right? Totally insignificant. But that's where it gets really deceptive. But here's the catch. The pH scale isn't like a ruler. It's logarithmic. And what that means is that tiny little 0.1 drop, well, it actually translates to a staggering 30 to 40% increase in acidity. So a tiny change in the number means a massive change in the actual chemistry of the water. So what does all this increased acid actually do? Well, this is the crucial part. It makes it way harder for marine creatures to get the calcium carbonate they need from the water. And that's the stuff they use to build their shells and skeletons. So essentially, the very building blocks for countless ocean creatures, they're starting to dissolve. Okay. So now let's track how this one single chemical change spirals into a much, much bigger problem. It basically kicks off a massive domino effect that starts to unravel the entire marine food web. I mean, from the tiniest little creatures all the way up to the fish that ends up on our plates.
Let's zoom in on one of these little guys, the pteropod. Scientists have a great name for them. They call them the canary in the coal mine for this whole crisis. They're these tiny sea butterflies, and they are a super important food source for so many other animals. But the problem is, their delicate little shells are just incredibly vulnerable to this new acidic water. And this is exactly where the chain reaction begins. First, the shell builders, like our little pteropods, they start to weaken and die off. Then, the fish that eat them, we're talking about things like salmon and cod, they can't find enough food, so they start to starve. That disruption ripples all the way up the food chain to whales and seabirds, throwing entire ecosystems off balance. And the final domino to fall? Well, that's us, human fisheries, the food security for billions of people, suddenly at risk. And if you think it stops with the food chain, think again. A sick, weakening ocean creates a crisis on 2 other massive fronts: our global climate and, believe it or not, the stability of our coasts. You see, the ocean does way more than just feed us. In a way, it actually breathes for the planet. Marine life is a huge part of this process called the biotic pump. Basically, tiny organisms at the surface suck up CO2, and then when they die, they sink to the bottom of the ocean, taking all that carbon with them and locking it away. But a sick ocean just can't run this pump very well, and that means more CO2 stays in the atmosphere, which, you guessed it, speeds up climate change.
Now, to put this all into a bigger perspective, just look at this. With ocean acidification now officially on the list, humanity has crossed 7 out of 9 of these critical planetary boundaries. 7. This isn't just one isolated problem we're talking about. It's a symptom of a whole planet being pushed dangerously out of whack.
So that's a lot of bad news. The big question is, what can we do about it? The good thing is, the report doesn't just drop this bomb on us and walk away. It actually lays out a clear path forward. This is the call to action part. And the experts are really clear on this. We need a massive, coordinated global response. First things first, we have to tackle the root cause by rapidly cutting fossil fuel use. That's number 1. At the same time, we need to protect and restore what are called blue carbon ecosystems. Think mangroves and seagrass beds that soak up enormous amounts of CO2. Then we have to support sustainable fisheries to make them more resilient. And finally, we've got to invest in better ocean monitoring so we can see these threats coming. When you boil it all down, the message of the report really comes down to this one simple, powerful idea. This isn't just about saving the whales or protecting pretty coral reefs. This is about realizing that our own fate is completely, 100% tied to the health of our oceans. For thousands of years, the oceans have been our silent guardian, right? They've absorbed so much of our pollution, they've buffered us from the worst of climate change. But that ability, that capacity, is fading. So the real question now is, after everything the oceans have done for us, are we finally going to step up and be their guardian?